Good morning, everybody. So, today I want to talk about framing basics, and I hope this helps some people who might consider doing some framing on their own at their house. And framing is not very difficult. It really isn't. However, there's a couple of rules that you want to have compliance. This way, when you get to your finished product, it's going to go on the way you want. And really, that is the key piece about framing. What is going on top of it, and how do I want my finished product to look? And it all starts with framing. So there is a rule about framing 16 inches on center. And that's imperative because your sheet of drywall is 48 inches wide, 8 feet tall. If you're doing a 10-foot ceiling, then obviously there's going to be some sort of belly band somewhere at 2 feet high, and that's not a problem. But again, your 16 on center is going to be imperative. And you want to start that from your corner where you have the longest run. So if you have a multitude of windows and then 10 feet of wall length, start from that corner. When you're doing your framing, make sure you use what's called a California corner. And that's going to be 3 pieces of wood in the corner, and that's going to give you the blocking you need for the corner to come to something solid. I can't tell you the number of times where I see drywall coming apart because there's no blocking behind it. People don't understand that. It's imperative that every seam in drywall have blocking. So 16 on center, what does that mean? Well, your first 2x4 starts at your corner. It's a 3-sided corner, so you have a flat and then a piece behind it. And you can look this up on the internet. Just look for California corner or how to frame a corner, and it'll be really obvious how that starts. Then you run all of your wall studs 16 inches on center. If you look at a ruler, you'll see that those 16, 32, 48, they're marked off with a box, and there's usually a red square or something around it. That is to help you frame your wall. And all you do is run your tape down there, mark off 16, 32, 48, and then so on, all the way down to the end. Then you take your ruler and 3/4 of an inch on either side of that 16, 32, 48, and so on mark. That's where the outside edge of your 2x4 lands. Then you nail that from the bottom and you nail it from the top. Now you are 100% assured, if you marked out everything properly, that your wall studs are perpendicular to the floor and everything lines up. So when you put your drywall on, your drywall edge is going to land halfway between that third stud. And that's where you join them. I have also seen people who do framing, they'll put 2 pieces of 2x4s next to one another and land the drywall that way. That could not be any more wrong. The reason being is those 2 pieces of wood are going to dry and twist and move at different rates. That is going to pull apart your drywall. And no drywall tape, yellow tape, is going to help you. So always land drywall on one stud. Always. Put your screw in at an angle so when you tape over it, as that 2x4 moves, expands, contracts, and bends, the whole wall moves as one unit. And the drywall will help keep that in place. The worst thing for a piece of wood is to be left hanging out somewhere. It's going to twist and bend. You see this with decks all the time. You see people who put a 6x6 on top of a patio. They don't secure the 6x6 to the patio, and that thing will twist. And even if you bracket it, it could twist. So, a word on wood, it has to be secured at both ends and not just a toenail. A toenail is not securing wood. It's holding it in place for you, but you need something to come from the top plate down into that 2x4 stud, at least two. Then you put your toenails in. And that toenail is just there mainly to keep the wood from twisting. That's it. So, think of it this way. If you have a nail coming in at an angle, right, it's going to be very difficult for the wood to twist and push against that angle. So that's why you want a toenail on either side and front and back. This way it keeps the wood in place and it's not going to twist on you. Because if it twists, that outside edge is going to push the drywall out. And if it pushes the drywall out, it's going to crack your seam. So make sure you nail off everything properly. At least 6 nails per top and bottom. 6 top, 6 bottom. This way, nothing moves. Okay, 16 on center. Then, when you get to your corner, make sure you have blocking at that corner. And then you just keep going all the way around. And the easiest thing to do is to build your wall, flip it up in place, nail it into place, put some sort of support so it doesn't move. Then when you're done, then you rack everything. Don't rack your walls as you build them. They're gonna move. It's a guarantee. Especially interior unsupported walls. Exterior walls, same thing. The wood will flex, and it's not a problem. Once you get the wall racked, and what I mean by racked is that the top dimension, let's say it's 200 inches, and you know that your corner is completely perpendicular. It's a 90-degree angle, and the bottom is 200 inches. If you push the top out, your tape measure is going to move, and it's going to open up that spread on that perpendicular corner. So, and then obviously side to side. And so rack your walls, get them so they're perfectly, everything is a 90-degree angle, and they're perpendicular to the floor. Once you have that done, then put your supports in. Then you can start nailing your corners together. If they're a little off, it's fine. It's not a big deal. You can cover it with sheathing anyway. And once you put the sheathing on, you staple it, not nail it. Some people like to glue it. You can. It's not a big deal. You staple your sheathing. Those staples have that top piece, a U, and it's going to hold that wood, and that wood is what's going to give you the lateral support that you're looking for. And believe it or not, drywall helps a great deal. Drywall will keep a wall in place. It's pretty strong, believe it or not. I know it's easy to put your fist through it, but from a shear perspective, it's pretty strong. Now, a note on windows. When you're framing your windows, you want what's called the rough opening from your window manufacturer. They're going to tell you what the space is between the window and the framing. And it is imperative that you have some sort of space between the window frame, whether it's fiberglass or plastic or wood-clad metal. You have to have a space. Some people think, oh, I'll just run the 2x4 up to the window and get rid of that airspace. No, it's not what you want. You want that space, and you want to fill that space either with insulation or foam. It doesn't matter. One product isn't superior to the other. All you're doing is closing up that air gap, but you're allowing the wood to expand and contract and not interfere with the window. Now, a note on vinyl windows. So vinyl windows don't have a lot of structural integrity. You'll see them in houses and they're sagging. So one thing you can do with a vinyl window is you can put a shim in the middle of a long vinyl window to keep it in place. If it's a 48-inch or a 60-inch window, then you could put a couple of shims and it's probably not going to hurt the window as long as you have expansion up top. But if you rest the window right on top of the wood sill, you're gonna have problems. And eventually, if it's a slider, that window probably won't open, and it could pop the glass. So when you get to a window, always, always, always put in your king studs, right? Put in your jack studs for your header, whatever that may be. You know, if it's a 48-inch window, you're probably looking at 2 jacks and 1 king. And those might be off 16 on center, but as soon as you lay those in, continue on with your 16 on center in the middle of that window. Same thing with your cripples up top. So you put your header in, and then you put your cripples. Some people like to put the header up top, just below the top plate, and that's fine too. The only thing with that is if you go to put in blinds or something, and you're maintaining your 16 on center, then you might miss a 2x4. So if you want to put the header at the top plate, totally cool. Doesn't matter where it's at. As long as it's supported by your jack studs, you're fine. If you're going to do that, I would suggest maybe putting in some 2x6 blocking above the window. This way, if you do buy blinds or something that's going to attach there, you're not just going into drywall. You're going into something solid. And you can do wings. So on the outside of that king stud, maybe run another 2x6 out to the next corresponding 2x4 or 2x6, whatever your wall is. This way, again, you've got something solid into which you can attach blinds and stuff that's heavy. This way it doesn't come out of the wall, because drywall anchors are going to fail over time, and they make a mess. And if you make a mistake, it's a lot easier to caulk up a hole from a screw than it is for a molly screw or those plastic things that are just ridiculous. They're a waste of time. So, and here we go into blocking. So with blocking, when you're framing out a room, anticipate where you might want a television, if it's a bathroom, where you might want a toilet paper holder, where you might want shelving. Just put the blocking back there. Put a couple of 2x8s or 2x6s. You can't miss it. I mean, if you miss a 2x8, you probably shouldn't be doing this anyway. So, put the blocking back there. Showers. When you frame out your shower, make sure you run a flat 2x4 with a 2x4 on its side. So now you got 3.5, inch and a half, inch and a half. Now you got 6.5 inches to hit, to hang your glass shower door or what have you. You're not going to miss it. You're going to hit it. And now you're not going just through tile and just through drywall. And that's, if anyone's ever done that, that is a pain in the neck. And it's going to come loose over time. When you have something that moves like that, you got to have something in solid wood. So 16 on center. Remember that. Follow that rule religiously. Mark it off. Use your speed square. Mark your center, and then mark 3/4 of an inch on either side. Blocking, important, imperative. Now, keep in mind, if your wall is over 8 feet tall, you're going to need a fire block at the 8-foot level. So just save your scraps, and then run your fire blocking at 8 feet. Then, when you're done, and your electrician shows up, and he'll just drill a hole right through it. You're going to put fire foam in there anyway, right? Because you got to draft stop it. So you just can't leave that hole open. That's what the inspector is going to look for. So another word about fire blocking. In a basement, if you already have flat insulation, it looks like a big plastic bag and it goes from floor to ceiling. Every 10 feet, you're going to need a fire block. And that could be something as simple as R19 insulation that's unfaced, that's not flammable. Or a piece of plywood that sits on that 2x4 and goes back to the wall. You don't have to cut the insulation out, just run it back to the insulation so it's tight and it'll pass inspection. Every 10 feet, you're going to need that. If you want to go overboard and insulate every single wall cavity down there, that's great. You're going to give yourself more insulation. It's not going to make the basement that much warmer because all of your cold air is actually coming up through the floor. So, unless the floor is insulated underneath your slab, running its extra insulation in the wall probably isn't going to do much. And if you have a window and it's a steel casement window, you're going to getting all that cold air in there anyway. I mean, you could put insulation behind the wall up to that steel casement, and that'll help to some degree. But some sort of R value blinds or drapes are going to help with that glass exposure. Because remember, you got to have your 4x3 escape window. That was a 24 square feet. So, and that's not so you can get out, it's so a firefighter can get in. But trust me, if there's a fire down there, you're going to be very thankful you got that square footage. You're going to love it. So those are the basics on wall framing. It's not rocket science, and the biggest key is when you're running your saw and you make your line, don't put the saw blade on the middle of the line. Your saw blade always goes off to the left, always. And use your speed square, if you're not that good, to make a straight cut. Not that hard. Just run your speed square on the 2x4, butt the saw up against it, run your blade just to the left of your pencil mark, and then make your cut. If you're really good and you can hold the 2x4 and let the saw drop and make the cut, that's even better, because it's going to be, you'll move much more quickly that way. So, some people will say, oh, just use a chop saw. Yeah, you can do that, but you got to set up a plank and you got to get everything level, and you don't want to make angle cuts because you want the wood to be tight between the 2x4 and your top plate. If it's not tight and there's a gap, you're going to fail your inspection. And if you can see the nails, you're going to fail. So, think of that. See the nail, it's a fail. Done. So use your skill saw and let the saw do the work, and let the weight of the saw bring the saw down. You don't have to push it. Just let the weight of the saw do the work. Boom. If you do that, the saw is going to fall in a straight fashion. Trust me, gravity will take over. If you've ever jumped out of an airplane, you will know this. You go straight down very quickly. And, of course, if there's a tailwind or a side wind, you have to compensate for that. But for the most part, anything that's heavy, and I weigh, 230 pounds, when I jump out of a plane, I go straight down. Trust me. So the saw is going to drop down, especially if your blade is sharp. Keep the blade sharp. People will use a blade that's so dull, and you'll hear the motor actually drawing down and pulling amperage to make the cut. If the blade's dull, toss it and get a fresh blade. It is your best friend. And you'll make every single one of those cuts. And here's the thing. If you're framing out the wall, 2x4 comes in different lengths. When you choose your 2x4, look at the height of your wall. If it's 8 feet and you got a bottom plate and 2 top plates, which you're going to want, you have 2 top plates, you're just going to take 96 inches minus the 4.5, and that gives you 92 5/8. It's already cut for you. Done. You build your wall, you tap it up into place, you plumb it, and you're done. Now, a word on walls and basements, especially where I live, where the ground moves a lot. They have to be floating. Again, not a big deal. This is not scary. All you do is you take little tiny cuts of 2x4. You put your bottom plate, which is pressure treated. You get your 22 shot, which is basically a 22 gun, and it shoots the nail into the concrete, and you glue it. You can use pressure treated wood, either red tone or green. Green's less expensive, and it's fine. It'll work. Put that on the floor, then take a 2x4 and lay it flat on top every 3 feet. Don't nail it. Don't do anything with it. Just lay it there. Then measure out your wall to the top and build your wall with 2 top plates. Put it on top of the 2x4, rack it in place, plumb it, nail it, and then pull the 2x4 out. And that allows the floor to move independently of the wall. Because if you don't do that, and the floor moves, it will move your house. Trust me, I've seen this. When soil expands, it expands at 292,000 pounds per square inch. There's nothing that man is going to build that's going to stop that from happening. It moves mountains. Your house isn't going to stop that from moving. And I've seen houses where people have framed walls improperly in their basement, and it has pushed their hallway up another inch. And they can't figure out why their closet doors don't open. Well, it's the floor pushing up on the wall. And you'll see the 2x4s. They're starting to bow and bend because of all the weight. And it's an easy fix. Cut the bottom off and make it floating. You're going to relieve all that pressure. Now, I'm not saying do that if your house has risen up. Call a professional and let them handle it. Because if you do that and a house drops, you could have bigger problems. So don't do that. But it is an easy fix for somebody who knows what they're doing. If you see this problem, call a contractor who knows what they're doing. Have them review what I'm telling you with you, and if they describe what I'm saying, they know what they're doing. Boom, let them go at it, and they'll relieve that pressure very slowly over time, so you don't break drywall and crack, floor joists and whatnot. You want that pressure to come. It went up slowly. You want it to come down slowly. So. Doors, interior doors, same thing. You don't need a header on an interior door. It's not necessary. I see a lot of houses built in the 70s. They got this 2x12 header up top for no reason at all. You don't need it. All you need is a king stud and a jack stud and one 2x4 across the top. When you nail your doors, you don't nail the top anyway. Don't ever nail the top of a door. When you're putting a door in, put the door in, close the door, look at your reveal, put a light behind it, and let the light shine through. And if the distance between the door and the frame is even on all sides, shim it and nail it. And if you want to, foam it. The foam is going to help keep the door in place. That door ain't going anywhere now. All you need is 18 gauge nails, 3 inches long. Put the nail through the shims. Don't shim and put the nail on either side. Over time, those shims are going to fall down and drop out, and then the door is going to move. Real simple. Put the shims in, boom, nail it. Put a level on it. Make sure that and I'm not saying level the door. What I'm saying is make sure that there's no undulations in the door frame. Make sure that the space between the frame and the level is perfectly even. If the door isn't even because of the floor and the way the house is, who cares? It's fine. As long as your reveal is spot on, then you're good. Because once you put your casing around, your casing reveal is going to be a 1/4 inch all the way around. That's imperative. It doesn't matter if the door isn't plumb. What matters is how does it fit in the space and what does the reveal look like? That's the only thing that matters. If you have to plane down the door, plane it down. It's not a big deal. Just make sure you don't plane down the knob side because then your doorknob isn't going to fit. So if you have to plane it down, plane on the hinge side and reroute the hinges. Done. Piece of cake. So, and you shouldn't have to do that. That's a very, we've worked on some homes that are built like in the 1800s and, everything's slanted and whatnot. And, the house is heaved and moved because, they've got these giant brick stanchions that are in the basement and they don't go below frost line and they've pushed the house up. So that's a very rare occurrence. If you work on a house that was built from the 50s on up, you're not going to have these problems. You're going to put the door in, you're going to look at your reveal and you're going to shim it and nail it and you're going to move on to the next one. And you'll get good at it. It'll probably take you 20 minutes to put in a door if you do it that way. Just use the light method. Don't measure. Just use the light method and look at the reveal. Your eye will tell you if it looks right. And then if it looks right, shim it and nail it. Done. And even if you do nail it and you close the door and you don't like the way the reveal looks, you can still move that door. You can pull it out. You can take out a shim and you can push it back in. You should go like that. Exterior doors, when you're putting in exterior doors, take the rubber trim off the frame. Give yourself a couple of screw holes, 5 or 6, doesn't matter how many, and then use a countersink. Then put the door in place and run those screws into the door frame. And there should be, again, a 1/2 inch to 3/4 of an inch gap between your framing and the door frame, the door jamb. Then get the screws in enough where you can close the door. Again, look at the reveal. You already have the rubber gasket off. You're going to see light coming in from the outside. If the reveal looks good, put the shims in, give yourself an 18 gauge nail right through the shims, right where your screws are, and then screw that in tightly, and then run your level, your 6-foot level up the door frame. And again, make sure there are no undulations or variations in the door frame. Make sure it's perfectly straight. And if you don't over tighten the screw, then you're going to be just fine. And again, foam it. Once you put the foam in and the foam dries, the screws only give it lateral support this way. The foam is going to give it support going this way, along with the shims to a certain degree. But that is more than sufficient for an outside and exterior door. Then once you put the foam sealant gasket back on, your screws are hidden. So once you paint the frame, you never see the screws. You don't have to caulk it and putty it and go through all this rigmarole. I see people do this all the time, and they got screws and nails all over the place, and it's a disaster. It's like you're making so much work for yourself. Put them behind the foam gasket, and you're done. So I hope that helps you in framing and door basics. I just want to touch on windows very quickly at the end of this. When you're installing your windows, and it's a flanged window, meaning that the window has a flange. So you're going to want your framing close enough to pick up that flange, but also a small gap to allow for expansion and contraction. And that's going to be a trick. The manufacturer will tell you what the rough opening for the window is. So if you buy it from Pella and they say your rough opening, it's going to say RO, is 31 inches, make sure that it is at 31 inches. Because what they're telling you is you're going to have enough room to install the window, shim the bottom, and then nail it into the framing on the nailing fin. The nailing fin is sometimes it's plastic or it could be metal. Metal's preferable because it's stronger. Plastic is going to sag over time. You can shim the bottom. If you foam it, the foam should keep it in place where it's not going to sink, but if you want to put a shim or two, it's not going to hurt the window. It'll be fine because you have that gap up top. If it pushes the window up, it's fine. It's not going to go anywhere. And the flange is designed. You'll notice the holes are a little bigger than your nails. Just use roofing nails. 1-inch roofing nails is all you need. Do not use screws. I'm begging you. Please. I've seen this a million times. People put screws all over the drywall screws through the flange. I mean, that couldn't be any more wrong. So get your tools, get your equipment, know what you need, have it on site, and do it right. There are 2 ways to do things, right or again. And if you do it wrong and all your finished material is on there, you're going to do it again. Trust me. And there's nothing worse than pulling off finished material and doing this for a second time. So use your roofing nails. You don't need every single hole. You need enough just to hold the window in place. And if it's a 36-inch window, every 4 inches is more than sufficient. All the way around. Now, on the bottom piece of your window, pan flashing. You can use metal if you're not good with tin snips and you don't want to cut yourself up and get a tetanus shot and bleed all over the place. Just get some flashing tape, and it's fine. Run it over the bottom. Run it up the sidewall about 8 to 10 inches. Overlap it. Don't cut the corners. Big mistake. The tape is meant to stretch. Pull the tape and run it on the bottom and then up. And then that corner, press it into the corner. And then on the front side, on this wall here, just run a piece of tape diagonally to hold that tape in place. Now you've got a complete watertight barrier because water is going to get back there. I can guarantee it. And even if you foam it, it's still going to get into the wood. So run your tape up. Then put your window in, nail it off, foam it, and then on the top, make sure you run your Z flashing. This way, when the water, and you tie that into your Tyvek, so when the water rolls down the Tyvek, which is what it's supposed to do, whether it's stucco or siding or whatever, the water's going to get back there. Especially if you live in an area where there's hurricanes and wind-driven rain, it's going to get behind the siding. And that's fine. That's what the Tyvek is for. It's designed to allow moisture out and no moisture in. When it rolls down the Tyvek and your Tyvek is sitting on top of your Z flashing, it's going to hit the Z flashing, roll over the window, and then down the front of the window. And that's exactly what it's supposed to do. Then, when you put your trim around the window, your top piece runs from outside corner to outside corner. And what I mean by that is, if this is the top of the side trim, the top piece runs to the outside corner of that piece. Another thing is, I forgot to mention, when you put the window in, make sure you caulk all three sides of the flange, not the bottom. Leave the bottom uncaulked. Caulk the top and the sides, and that'll make a nice tight seal up against your Tyvek. The bottom leave uncaulked, because if water does get back there, you want it to roll out. And it's going to roll out on top of your Tyvek, which is already wrapped over your framing. It'll hit the Tyvek, drop down, and roll right out onto the ground where it's supposed to go. So, and you can look up a visual online. Go to Pella's website. They got a great install on this, and you can't go wrong. And I hope this verbal helps you with the visual so you understand how to do this. And once you do one window, it should take you an hour at the most. You can start knocking these out like that. 20 minutes per window at best. I mean, you should have this down in no time. Piece of cake. Make sure you plumb the window and just take a diagonal measurement from corner to corner. And if they're both the same, now you know the window isn't tilted. I mean, you could use a level on the side and the top, that's fine too, or just do a crisscross measurement. Either way is acceptable. You know, if it's within a 1/16 of an inch, it's going to be fine. It's not going anywhere. Then once the foam is dried and everything's in, test the window, make sure it opens, look at the reveal on the inside, same thing as a door. If it needs to be shifted for whatever reason, shift it. If it's not exactly perpendicular or plumb, but the reveal looks good, then that's fine. And there could be a manufacturing defect, who knows? The most important piece is the reveal and the function of the window. That's more important than being exactly plumb. You might be off by 1/8 of an inch, but again, it's not that big of a deal. Now, on the outside trim, make sure that your bottom piece only goes to the outside edge of the window, and what's called your leg, which is on the side, drops down and covers that piece that's on the bottom. So it's going to look flat like this, and right here on the outside is where the leg comes down. The reason for that is, as water rolls out the weep holes, you don't want that bottom piece to extend beyond the edge of the window. Otherwise, it's going to start to rot. You want the legs to come down. And again, that's just for water extrusion. And it may look weird to you. You may want the whole thing to be boxed out, top and bottom the same. It's not how it's supposed to look. That's not how you do it. The bottom is supposed to be shorter than the top, and that's how you want that. And make sure you put some Z flashing in. Put it on top of your trim, run it back. This way, when the water does get on top of the wood, it hits the Z flashing and drops right out. Now you got Z flashing at the top trim, on top of the window, and on top of your bottom trim. Now you're fully protected. You know that window is not going to leak. Because if it is leaking, you won't know it. It won't reveal itself for a long time. And by the time you figure it out, the damage is already done. But if you do it this way, you're not going to have any problems. So I hope that helps you. If you have any questions, you're not sure what we're talking about, how this is supposed to look, send me over a comment and we'll be more than happy to answer your questions. And again, if you're in the Colorado area and you need help with windows, you need window install, any type of construction services, contact us here at MTD Construction and we'll make sure that it gets done correctly. Thanks for viewing.